You're watching China fuse 11 separate cities into the largest urban zone ever created by human hands. We're talking about 86 million people, more than the entire United Kingdom, being physically connected into one functioning megacity through the most ambitious infrastructure project on Earth. This isn't some distant vision or urban planning fantasy. The bridges are built, the tunnels are carved, the high-speed rail is running, and right now, millions of people are living in a reality where 11 cities operate as one. The Greater Bay Area isn't just big, it's a $2 trillion economy, larger than Russia, powered by engineering that makes the impossible routine. And it all starts with understanding which 11 cities are actually being merged together. The 11 cities becoming one. The Greater Bay Area isn't a concept. It's 11 distinct cities with 11 different identities being welded into a single megalopolis. Guangzhou, the ancient trading capital. Shenzhen, the tech manufacturing beast that rose from fishing village to metropolis in 40 years. Hong Kong, the global financial center. Macao, the gaming hub. Then Zhuhai, Foshan, Dongguan, Zhongshan, Jiangmen, Huizhou, and Zhaoqing, each one a major city in its own right, each contributing specialized economic power to the whole. Together, these 11 cities cover 21,000 square miles, roughly the size of West Virginia, packed with 86 million people. That's more than the entire population of Germany, more than France, more than the United Kingdom or Italy, and double the population of Canada. And their combined economy? $1.9 trillion. If the Greater Bay Area were a country, it would rank as the 11th largest economy on the planet, bigger than Russia, bigger than South Korea, bigger than Australia, Spain, and Indonesia. But here's the problem these 11 cities faced. They were separated by one of the most complex waterway systems on Earth, the Pearl River Delta. Rivers, estuaries, shipping channels, and open sea carved the region into isolated zones. Guangzhou sat in the north. Shenzhen hugged the eastern shore. Hong Kong and Macau were separated by 34 miles of open water. Traveling between them meant hours of ferry rides, congested highways, or indirect routes that turned short distances into half-day journeys. China looked at this fragmented region and made a decision that seemed impossible: connect every single point to every other point in under 1 hour. Not by asking people to move, not by abandoning existing cities, by building the infrastructure to make 11 cities function as one. The investment required? Over $150 billion in bridges, tunnels, high-speed rail, metro lines, expressways, and digital systems. And the first step was solving the most impossible connection of all, linking Hong Kong, Zhuhai, and Macau across 34 miles of open sea. The bridge that defied the ocean. Imagine standing on the shore of Hong Kong, looking west across 34 miles of open water toward Macau and Zhuhai. For decades, that crossing meant a 4-hour journey by ferry, or an even longer route driving north around the entire Pearl River Delta. The water between them wasn't just wide, it was one of the busiest shipping lanes on the planet, with massive container ships passing through every hour. Building a bridge seemed impossible. China built it anyway. The Hong Kong-Zhuhai-Macao Bridge isn't just a bridge. It's a 34-mile engineering monster that combines bridges, artificial islands, and underwater tunnels into one continuous crossing. $20 billion, 7 years of construction, 400,000 tons of steel. When it opened in 2018, it became the longest sea-crossing bridge tunnel system ever built by human beings. But here's where the engineering gets insane. You can't just build a bridge across one of the world's busiest shipping lanes. The container ships are too tall, and blocking them would strangle global trade. So engineers designed a 4-mile underwater tunnel section, sinking it beneath the shipping channel to let vessels pass overhead. To connect the tunnel to the bridge sections, they built 2 artificial islands in the middle of the ocean, each one the size of 20 football fields, constructed by sinking massive steel cylinders into the seabed and filling them with sand. Then came the environmental nightmare. The waters between Hong Kong and Zhuhai are home to Chinese white dolphins, an endangered species that couldn't survive traditional pile-driving construction methods. Engineers had to develop entirely new techniques, using prefabricated sections built onshore, then floated into position and lowered into place to minimize underwater noise and disruption. Every piece had to fit with millimeter precision, and the bridge had to survive nature's worst. This is typhoon territory, where winds hit 125 miles per hour. The entire structure was engineered to withstand wind speeds up to that level, with cable-stayed sections designed to flex and absorb the force rather than resist it. It sits in a seismic zone, too. The whole system can handle an earthquake up to magnitude 8 without catastrophic failure. When the bridge finally opened, the impossible became routine. Hong Kong to Macau, a journey that took 4 hours, now takes 30 minutes. Hong Kong to Zhuhai, 45 minutes. The western and eastern sides of the Greater Bay Area, separated by geography for millennia, are now connected by a continuous ribbon of concrete and steel. You can drive from one end to the other without stopping, crossing from Hong Kong's skyscrapers to Macau's casinos to Zhuhai's manufacturing zones in less time than most people spend commuting to work. But connecting the edges of the Greater Bay Area was only the beginning. The real challenge was fusing the cores of the 3 largest cities together. The high-speed rail tunneling beneath cities. Guangzhou, Shenzhen, and Hong Kong formed the beating heart of the Greater Bay Area, 3 massive city centers holding over 40 million people combined. For decades, traveling between them meant slow conventional trains, congested highways, or ferry crossings that turned what should be short trips into multi-hour ordeals. Moving between these 3 economic powerhouses was like trying to run a marathon with your legs tied together. China's answer was the Guangzhou-Shenzhen-Hong Kong Express Rail Link, 88 miles of high-speed rail connecting 3 city centers at 218 miles per hour. The trains themselves weren't the hard part. The hard part was where to put the tracks. You can't build elevated high-speed rail through the densest urban areas on Earth without demolishing entire neighborhoods. And building at ground level? Impossible. There's no space left. So engineers made a decision that seemed insane. Put the entire rail line underground. 16 miles of tunnel carved through solid rock beneath some of the most expensive real estate on the planet. In Hong Kong alone, the tracks run 98 feet underground, with West Kowloon Station built as a massive subterranean complex covering 4.6 million square feet, one of the largest underground railway stations ever constructed. But here's the engineering nightmare nobody talks about. You're drilling tunnels through densely populated urban zones where millions of people live directly above the construction. One mistake, one miscalculation, and buildings collapse. Vibration control became obsessive engineers, designed the tunnel boring machines to operate with such precision that residents in apartments 98 feet above the tunnels couldn't feel the excavation happening beneath. And when trains eventually ran through those tunnels at over 125 miles per hour, the vibration had to remain imperceptible. Then came the pressure problem. Trains moving at 200 miles per hour through tunnels create pressure waves, compression waves that build up ahead of the train and can cause passenger discomfort, structural stress, and in extreme cases, sonic booms when trains exit tunnels. Engineers had to design pressure relief shafts, aerodynamic train nose shapes, and tunnel cross-sections that allowed air to escape around the train without creating dangerous pressure spikes. The West Kowloon Station itself became a technical marvel. Built 98 feet underground in one of the world's most expensive cities, the station had to be excavated without disrupting the buildings above it. Engineers used a top-down construction method, building the roof first to support the surrounding structures, then excavating downward beneath it. The station sits beneath a park and skyscrapers, invisible from the surface except for its entrances. When the express rail link opened in 2018, the impossible became routine. Guangzhou to Hong Kong, a journey that previously took over 2 hours on conventional rail, now takes 48 minutes. Shenzhen to Hong Kong, just 14 minutes. You can have breakfast in Guangzhou, attend a morning meeting in Shenzhen, close a business deal in Hong Kong by lunch, and be back in Guangzhou for dinner. 3 cities, 40 million people, connected by trains moving beneath their feet at speeds that turn geography into irrelevance. The trains carry over 80,000 passengers daily between the 3 cities, pumping $8.6 billion into the regional economy every year, just from the time saved and business enabled. 3 separate cities started operating as one urban core. But high-speed rail only connected the major centers. To truly make 11 cities function as one, you needed transportation, reaching into every neighborhood, every district, every corner of the megalopolis. The metro lines, weaving an underground web. High-speed rail connects city centers, but it doesn't get you from your apartment to your office, from a factory in Dongguan to a research lab in Shenzhen, from a port in Guangzhou to a tech campus in Foshan. For that, you need metro systems, and the Greater Bay Area wasn't building separate metro systems, it was building the largest interconnected underground network on Earth. Guangzhou, 15 metro lines stretching 377 miles, the 3rd longest metro system in the world. Shenzhen, 16 lines covering 262 miles, the 7th longest globally. Add Foshan, Dongguan, Huizhou, and Zhongshan, and you're looking at over 746 miles of metro track. That's more than New York, London, and Paris combined. But here's what makes this insane. These metros were designed from the beginning to merge into one network. Guangzhou's Line 3 doesn't stop at the city limits, it keeps going straight into Foshan without passengers even noticing they've crossed into another city. Shenzhen's Line 10 extends into Dongguan. The lines blur together, creating an underground web that ignores political boundaries. But making this work meant solving a nightmare. Different cities built their metros at different times, with different technical standards, different platform heights, different power systems, different signaling technology. Engineers built cross-compatible trains that could switch between power systems on the fly, designed universal platforms that worked with different train heights, and created signaling systems that could communicate across different protocols. Then came the construction challenge, tunneling beneath cities that are already dense, already built, already operating existing metro lines. Guangzhou's construction sometimes required boring new tunnels directly beneath existing metro tunnels, with just 30 feet of rock separating them. Tunnel boring machines had to operate with such precision that trains running above didn't even register the vibration of construction happening below. When you ride the metro from Guangzhou to Foshan now, there's no border, no ticket change, no transfer. The train just keeps going. Your Metro card works across all 11 cities. One tap gets you onto any train in the entire Greater Bay Area. The system processes over 20 million trips every single day. 20 million people moving through an underground network that treats 11 cities as one seamless grid. By 2025, the Greater Bay Area is targeting 1,430 miles of metro track, more than double what exists now. New lines are connecting Hong Kong's metro directly to Shenzhen's, linking Zhuhai to Macao, extending Guangzhou's reach to every corner of the region. But underground rail only works when you're already in the cities. To truly connect 11 cities across 21,000 square miles, you need to conquer the surface. The bridges that conquered the Pearl River Delta. Metro lines move people underground. High-speed rail connects city centers. But to truly make 11 cities function as one, you need something more fundamental. You need roads, highways, bridges that let millions of vehicles flow freely across a region carved apart by rivers, estuaries, and open water. And the Pearl River Delta isn't just one river, it's a maze of waterways that splits the Greater Bay Area into isolated zones. China's solution was to build bridges so massive they redefined what's possible. Start with the Human Second Bridge, 8 miles of suspended roadway spanning the Pearl River with a main span stretching 5,538 feet. The bridge carries 6 lanes of traffic across waters so wide you can't see the other side from the middle. It opened in 2019 and immediately started handling over 100,000 vehicles every single day. Then there's the Nansha Bridge, connecting Guangzhou and Dongguan across another section of the Pearl River. Another massive suspension bridge, another critical link in the surface network. But these bridges weren't enough. Engineers looked at the map and saw the biggest gap of all, Shenzhen to Zhongshan, separated by 15 miles of open water and shipping channels. Building a bridge there seemed impossible for the same reason the Hong Kong Zhuhai Macao Bridge was impossible shipping lanes. Container ships heading to and from Shenzhen's port can't stop just because someone wants to build a bridge. So engineers designed the Shenzhen Zhongshan Bridge as another hybrid monster. 15 miles of bridge tunnel system combining cable-stayed bridges, underwater tunnels, and artificial islands, all built across some of the deepest, fastest-moving water in the delta. But here's where it gets insane. The underwater tunnel section alone stretches 4 miles, and it's not built on stable seabed, it's built through soft sediment and mud that shifts with tides and currents. Engineers had to sink tunnel sections weighing over 76,000 tons each, lowering them into position with such precision that the margin of error was measured in inches. One miscalculation, and the tunnel sections don't align, leaving gaps that flood with seawater under millions of pounds of pressure. The tunnel sits beneath a shipping channel where the world's largest container ships pass overhead ships so heavy they displace thousands of tons of water, creating pressure waves that pulse down to the tunnel below. The tunnel structure had to be engineered to handle not just static water pressure, but dynamic pressure fluctuations from passing ships, while also remaining flexible enough to handle seismic activity without cracking. And the bridges themselves, the cable-stayed sections, use towers that reach 960 feet into the air, taller than most skyscrapers, anchored to foundations driven 300 feet into the seabed. The cables holding up the roadway are each composed of hundreds of individual steel strands, tensioned with such precision that the bridge deck remains perfectly level, even as temperature changes cause the cables to expand and contract by several inches. When the Shenzhen Zhongshan Bridge opens in 2024, it will erase a 2-hour journey. Shenzhen to Zhongshan will take 20 minutes. The eastern and western sides of the Greater Bay Area, currently separated by geography and time, will be connected by a continuous roadway that treats open sea like a minor inconvenience. And it's not just these mega bridges. The Greater Bay Area has built over 12 major expressways crisscrossing the region, creating a ground network totaling over 3,100 miles of highway. That's higher expressway density than the Los Angeles metropolitan area. You can get from any city to any other city in under 1 hour, now not by train, but by car, giving millions of people the freedom to live in one city and work in another without being chained to rail schedules. But bridges and highways move people and goods on the surface. For a region competing to be the world's economic powerhouse, you need to dominate the sky. The 5 airports forming an aviation supercluster. Most mega regions have 1 major airport, maybe 2 if they're lucky. The Greater Bay Area has 5 massive international airports packed into 21,000 square miles, and instead of competing against each other into irrelevance, they're being integrated into the largest aviation hub cluster ever created. Start with Hong Kong International Airport, 74 million passengers annually before the pandemic, consistently ranked among the best airports on Earth. Then Guangzhou Baiyun Airport, handling 73 million passengers and expanding capacity to 120 million. Shenzhen Bao'an Airport with 52 million passengers. Zhuhai Jinwan Airport handling 14 million. Macao International Airport with nearly 10 million. Combined, these 5 airports currently handle over 220 million passengers every year. That's more than all of New York's airports combined, more than London's airport system. And China isn't satisfied with current capacity. They're expanding. But here's the problem that seemed impossible to solve. 5 major airports in one region should cannibalize each other. Airlines should refuse to serve all 5. Passengers should get confused about which airport to use. Air traffic control should become a nightmare, with 5 airports sharing the same airspace, their approach and departure paths crossing over each other like a game of 3-dimensional chess played at 500 miles per hour. China's solution was to turn competition into coordination. Instead of letting the airports fight for the same routes, each airport was given specialized roles. Hong Kong focuses on international long-haul flights and cargo. It's the gateway to the world. Guangzhou handles domestic Chinese routes and connections to Asia. Shenzhen specializes in tech industry, business travel, and regional flights. Zhuhai and Macao serve niche markets and overflow capacity. But specialization only works if passengers can actually get between airports and cities quickly, and that's where the engineering gets interesting. Engineers built high-speed rail connections directly into the airports. Hong Kong Airport is getting a direct high-speed rail link. Guangzhou Baiyun already has metro and high-speed rail running directly into the terminal. Shenzhen Airport connects to the metro system and will soon link to Hong Kong via high-speed rail in just 15 minutes. This creates something that doesn't exist anywhere else: seamless air-rail integration across 5 airports. You can fly into Hong Kong, take a 15-minute train to Shenzhen Airport, and catch a connecting flight without ever dealing with ground traffic. You can land in Guangzhou, take high-speed rail to Hong Kong, and be in central Hong Kong, faster than a taxi could get you there from the airport. Then came the airspace problem. 5 airports mean 5 sets of approach paths, 5 sets of departure corridors, 5 sets of holding patterns for delayed flights. Get this wrong and you create mid-air collision risks, or force planes to circle for hours waiting for clearance. Air traffic control had to be unified across all 5 airports, one centralized system coordinating every takeoff and landing across the entire Greater Bay Area, treating 5 separate airports as one distributed hub. And the expansion isn't finished. Hong Kong Airport just completed its 3rd runway, adding capacity for 30 million more passengers annually. Guangzhou Baiyun is expanding to handle 120 million passengers, more than any single airport in the United States. When all expansions are complete by 2030, the Greater Bay Area's 5 airports will handle over 300 million passengers every year. 300 million. That's nearly the entire population of the United States flowing through one region's airports annually. But moving people through the air is only half the economic equation. The Greater Bay Area's real power comes from moving goods across the ocean. The economic monster that emerged. All of this infrastructure, the bridges, the tunnels, the high-speed rail, the metro lines, the expressways, the airports, wasn't built just to move people faster. It was built to fuse 11 separate economies into one economic monster that rivals entire nations. And it worked. The Greater Bay Area's combined GDP hit $1.9 trillion, the 11th largest economy on Earth if it were a country. Bigger than Russia's entire economy. Bigger than South Korea. Bigger than Australia, Spain, and Indonesia. 86 million people generating more economic output than nations with twice the population. But here's what makes this terrifying. For the rest of the world, this is just the beginning. By 2035, the Greater Bay Area's economy is projected to hit $4.6 trillion. That would make it the 4th largest economy on the planet, exceeding Germany's current GDP. One region in China, containing 11 cities that were separate just years ago, operating as an economic force larger than almost every country on Earth. Shenzhen pumps out $490 billion in GDP, dominating global tech manufacturing. Hong Kong's $370 billion economy controls financial flows across Asia. Guangzhou's $380 billion trade hub connects Chinese manufacturing to the world. And the smaller cities, Dongguan, Foshan, Zhuhai, each one contributes tens of billions in specialized industries, feeding an ecosystem where innovation, manufacturing, finance, and logistics operate as one integrated machine. The infrastructure made this possible. Because of the bridges, a factory worker can live in Zhongshan and work in Shenzhen with a 20-minute commute. Because of the metro, an engineer can collaborate with teams across 3 cities in one day. Because of high-speed rail, a CEO can manage operations in Guangzhou, meet investors in Hong Kong, and tour manufacturing facilities in Dongguan without losing a full day to travel. 11 cities stopped competing and started multiplying each other's strengths. And the results show up in the numbers that matter. 58,000 high-tech companies concentrated in one region. $60 billion in research and development spending annually, more than South Korea's entire R&D budget. 680,000 patent applications every year, more than the United States and Europe combined. This is what happens when you stop treating cities as separate entities and start treating them as one organism. When you build infrastructure so complete that geography becomes irrelevant. When 86 million people can move freely, work anywhere, collaborate seamlessly across what used to be insurmountable distances,